A polyhydric alcohol has a molecular mass of 240. When the alcohol is treated with excess of acetic anhydride, it forms an acetyl derivative having the molecular mass. It is not formula, mass of 366. The number of hydroxy groups present in one molecule of alcohol is. Okay, they are asking us to find out the number of hydroxy groups present in one molecule of alcohol. Molecular mass of alcohol is given, molecular mass of acetic derivative is given, and they are asking us to find out the number of hydroxy groups. How to solve this? Molecular mass of alcohol. What is the molecular mass of alcohol given? 240. Then molecular mass of acetyl derivative of alcohol. Acetyl derivative of alcohol. It is 366. What is the difference in the molecular mass here? Difference in the molecular mass is 366 minus 240. That is 126. Okay. Now let us see the reaction. Alcohol reacts with acetic anhydride. What will you get? ROCOCH3 plus CH3COOH. Means H of alcohol is replaced by COCH3 group. So when one OH group of alcohol is reacting, what will be the change in the molecular mass of the alcohol? Let us find out now. So what is the molecular mass of CH3CO group? It is 43. Molecular mass of hydrogen is 1. So 43 minus 1 is 42. Means when one hydrogen of alcohol is replaced by one acetyl group, the change in the molecular mass of alcohol will be 42. Okay. But what is the total change here? Total change in the molecular mass. Total change in the molecular mass is 126. Change in molecular mass per one alcohol, for one OH group. If there is only one hydroxy group, the change in molecular mass is 42. So how many hydroxy groups are there? 126 divided by 42. That is 3. Means the polyhydric alcohol is having 3 hydroxy groups. Let us check. So B is your answer.